In this question, they have asked us to find out the incorrect statement. So, if we see statement number 1, that is option number 1, clay deposit with a liquidity index greater than unity is in a state of plastic consistency. But if liquidity index greater than 1, then soil behaves as liquid where said to be in a state of liquid consistency. So in this question, option A is the right answer. Now let us write down the given data in this question. Given they have given us the liquid limit equal to 60 percentage or 0.6. We will directly write this 60 percentage. Plastic limit as 27 percentage and natural moisture content 32 percentage. Also they have given us the flow index it as 27 percentage. Now they have asked us to find out the toughness index and liquidity index. So with liquid limit and plastic limit, we can find out the plasticity index, which is equal to IP is equal to WL minus WP. 60 minus 27, which will be equal to 33. So IT, toughness index IT, which is equal to IP by IF. Plasticity index minus by flow index 33 by 27, which will be getting it as 1.22, and liquidity index IL is equal to WN minus WP divided by WL minus WP. So WN 32 minus WP 27 divided by WL 60 minus 27, 5 by 33, which will be 0.151. Let us write down the given data from this question. They are given that natural moisture content means water content is equal to 0.25 and bulk unit weight which is equal to 18.5. Also they have given the specific gravity G is equal to 2.65 and unit weight of water is 9.81. They've asked us to find out the unit weight of soil sample on full saturation. So saturation will be 1. At full saturation, we need to find out the unit weight of soil. We know that gamma D is equal to gamma by 1 plus W. Also, gamma D is equal to G gamma W by 1 plus E. So comparing both these equations, we can come to know that gamma by 1 plus W is equal to G gamma W by 1 plus E, because they have given us the bulk unit weight, they didn't given us the dry unit weight. So we can proceed with this. We can find out the dry unit weight and also we can proceed this question, but we will go with the bulk unit weight. So 18.5 divided by 1 plus 0.25 equal to 2.65 into 9.81 divided by 1 plus E. By solving this question, we get E as, from this equation, we come to know that E will be equal to 0.756. Now, they have asked us to find out the unit weight of soil at full saturation. So we know that gamma equal to, from the functional relationship, G plus SE gamma W divided by 1 plus E. Here G equal to 2.65 plus S will be equal to 1 into E equal to 0.76, gamma W equal to 9.81 divided by 1 plus 0.76. Therefore, gamma is equal to 19.03 kilonewton per meter cube. Now, let us write down the given data from this question. They have given in a constant head permeability test, they have given the hydraulic gradient as 2.5, I equal to 2.5. Soil specimen has a specific gravity which is 2.65, and see this saturated water content of 20% means the soil is saturated and the water content of that soil to make it completely saturated is 20%. So soil is completely saturated means degree of saturation is 1, water content is equal to 20% or 0.2. You have to note down. In a single statement they have given the data of two values, and also they have given the coefficient of permeability, which is K is equal to 0.1 centimeter per second. Now they have asked us to find out the seepage velocity. Solution. If we see Sevag equation, we will be able to find out the E value, which is Wg by S 0.2 into 2.65 divided by S, which will be equal to 0.2 into 2.65 divided by S, which will be equal to 0.53. Now, porosity N is equal to E by 1 plus E, that is 0.53 divided by 1 plus 0.53, which will be equal to 0.53 divided by 1.53, that is equal to 0.3464. Seepage velocity formula of seepage velocity Vn is equal to Vs is equal to V by N. So V is equal to Ki by N. K they have given us 0.1 into I 2.65 divided by N 0.3464, which will be equal to 0.25 divided by 0.3464, which will be equal to 0.72 centimeter per second. It's the right answer. In this question, they have given that sample of 500 gram dry sand. So we'll write down the given data. 500 gram dry sand means mass of sand is equal to 500 grams. You should not take it as weight. And when poured into a 2-liter capacity of cylinder, which is partially filled with water, displaces 188 centimeter cube of water. Means if you pour the sand in 2 liter cylinder which has been filled with water, it has been displaced 188 centimeter cube of water, which means the volume occupied by the sand is 188 centimeter cube. So also they have given the density of water as 1 gram per centimeter cube. And now they have asked us to find out the specific gravity of the sand. Solution. So mass by volume we can get the density. Density of sand is equal to mass of sand by volume of sand, which is 500 divided by 188, which will be equal to 500 divided by 188, 2.659. Also, specific gravity of sand Gs is equal to sigma S by sigma W. Density of solids divided by standard density of water. So 2.659 divided by 1, which will be equal to 2.659, or you can take it as 2.66. So option B is the right answer. Let us write the given data in this question. A soil has dry weight of 15.5 kilonewton per meter. Means dry unit weight of soil is 15.5 kilonewton per meter cube. Specific gravity they have given us 2.65, and degree of saturation, it is 72%, which is 0.72, and they have also given the unit weight of water as 10 kilonewton per meter cube. And now they have asked us to find out the water content of the soil. So we'll come to the solution. So with the given data, gamma D is equal to G gamma W by 1 plus E, where we can find out E. So 15.5 equal to 2.65 into 10 divided by 1 plus E. 1 plus E is equal to 26.5 divided by 15.5, whereas E is equal to, we calculate, 26.5 divided by 15.5 minus 1, 0.71. E will be equal to 0.71. So then we can, from the Sehwag equation, we can find out the water content of the soil, which is equal to Se by G. So S is equal to 0.72 into 0.71 divided by 2.65, which will be 0.72 into 0.71 divided by 2.65, 0.1929, or 19.29 percentage. Hello guys, I welcome you all to another video. Now, if you see in this question, it is given that the specific gravity of solids is equal to 2.65, and mass density of water is 1000 kilogram per meter cube. And see, this one you have to note, zero air voids. This is the important keyword in the question, zero air voids. And moisture content is 10%. Now they are asking us to find out the dry density. So first we will write down the given data. Specific gravity of solids is 2.65. mass density of water is equal to 1000 kilogram per meter cube. Moisture content, that is water content, is equal to 10 percentage or 0.1 solution. So from the functional relationship formula, we can say that dry density is equal to G sigma W by 1 plus E. So we have G and sigma W, we don't have E. So to find out E, we can come from the Sevag equation. See, in this equation, we don't know the value of S, but it has been given that 0 air voids. So volume of air equal to 0. So total volume of soil will be volume of water plus volume of solids. Therefore, degree of saturation is equal to 100 percentage. So S is equal to 1. 1 into E equal to 0.1 into 2.65. Therefore, E equal to 0.265. Then sigma D equal to 2.65 into 1000 divided by 1 plus 0.265. Which gives us 2094.86 kilogram per meter cube. Now we'll write down the given data in this question. So they have given uncompacted heap of soil has a volume of 10,000 meter cube. So volume of soil uncompacted, which is 10,000 meter cube. Also they have given us the void ratio of 1. So E is equal to 1. Also they have given the soil is compacted to a volume of 7,500 meter cube. So they are asking us the volume of soil at compacted, which is 7,500 meter cube. Now they are asking us the void ratio. So E uncompacted, E compacted. Here volume of soil solids are same. So from this equation V1 by 1 plus E1 equal to V2 by 1 plus E2, where we can take it as uncompacted as V1, E1, and this one V2, and this one as E2. So V1 10,000 divided by 1 plus 1 equal to 7,500 divided by 1 plus E2. From this, we get that E2 will be equal to 10,000 by 2, 5,000, 7,500 by 5,000 minus 1, which is 0.5. From this question, we can write down the given data. So given they have given specific gravity of soil, it is 2.6, and the soil is at 50 percentage degree of saturation with a water content of 15 percentage. So degree of saturation, it is 50 percentage or 0.5, and water content, it is 15 percentage or 0.15. Now they have asked us to find out the void ratio. Very simple. It is a direct question. From the Sevag equation, we can find out the void ratio. So E is equal to Wg by S. So 0.15 into 2.6 divided by zero point 0.5, which gives 0.15 into 2.6 divided by 0.5, 0.78. Option B is the right answer.